Hi Tennis. If you remember, just before Christmas, we just finished Unit 3, the algebra topic. We literally finished the stuff on our last lesson before Christmas, which meant we didn't get a chance to do the test. Now, you can probably guess where this is going, and you're right. So next lesson, which I think is Monday, you're going to be doing your Unit 3 test. Okay, so I'll just be uploading it as an attachment, and if you can print it and write on it, brilliant. If not, then you can just answer on a page, and then you will be uploading your answers for me to mark. Okay, so what we're going to do today is just recap everything that we learnt in that algebra topic, and there'll be lots of points for you to pause and continue on with the video. So we'll cover something, I'll remind you what exercises we did on that, then I'll give you the answers to the exercise so that that gives you a chance. You pause the video, try the questions, and then go on and check your answers. Okay, you don't have to do every single question from each exercise, you literally wouldn't have the time, but just focus on the ones where you know you're weakest. Okay, right, so let's start. Okay, so the first thing we did in this topic was multiplying out single brackets. So I've just written out 3 wee examples here to remind you of the process. So remember, if you have a number or a letter or something right beside a bracket, it means that absolutely everything in that bracket must be multiplied by that number, or it could be a letter. So for this one here, it would be 3 multiplied by 5x would give us 15x. And then 3 multiplied by minus 4 would give us minus 12. Okay, this one, I've added this in on purpose because sometimes people get confused. They'll not apply BIDMAS and they'll add these together and multiply everything by 5, but that's wrong. It's only the thing that is directly beside the bracket that you multiply by. Okay, so our next line in this would be 1 plus 4 has to get multiplied by 8 to give us 32. 4 multiplied by y gives us 4y. And then with one like this, you would tidy up. So 1 plus 32 would be 33 plus 4y. And we can only collect like terms together, so terms which are of the same type. Okay. Last wee one here. Again, I've picked this one on purpose just to reiterate something. So 15 minus this bracket. See, if you have one like this, it's as if there should be minus 1 in front of that bracket, which means everything in this bracket has to be multiplied by minus 1. So my next line for this one would be 15 minus 1 multiplied by 3x gives me minus 3x, and minus 1 multiplied by minus 5 gives me plus 5. And then for my tidying up for that one, 15 minus 3x plus 5, I could gather my 15 and my 5 together because they're like terms. They're terms of the same type. So 20 minus 3x. Okay, so here's an exercise that will give you some practice at doing that. You don't have to do every single question, just be sensible. So if you pause the video, do a few of those, then come back and check the answers. So here's our answers to 6a. So again, pause, mark what you did, and then let's go on. Right, next wee bit then, multiplying double brackets. So again, we'll just do a few examples. So if you've got 2 brackets beside each other like this, it really means absolutely everything in this bracket has to be multiplied by absolutely everything in this bracket. And the method that we use for this is to do our wee smiley face combined with FOIL. And FOIL, first, outer, inner, last, is just the way we remember, I suppose, the order to do things in, which isn't important. It's more important that we remember to multiply everything by everything. So if we have a system for that, it means we're less likely to forget about something. So first means multiplying, so I'll write the word FOIL here actually to remind you. Right, first means multiply the first term by the first term. So x multiplied by x gives me x squared. O for outer means I'm multiplying the outer 2 terms together. So x multiplied by 7, I would write that as 7x. Inner, for multiplying the 2 inner terms together. Minus 4 multiplied by x minus 4x, and then last terms together, minus 4 multiplied by 7 is minus 28. Now, whenever we've got this, we have to gather our like terms together. So x squared, we've no more x squared terms there, we can't join anything together. 7x minus 4x, they are like terms, they're both x terms. So 7x take away 4x is 3x. And then we have minus 28 still. So that would be the final answer for that one. Right, let's look at this one then. So first, 2x multiplied by 5x. I tend to do numbers first and then letters. So 2 multiplied by 5 gives me 10. X multiplied by x gives me x squared. Outer, 2x multiplied by 4, 8x. Inner, 3 multiplied by 5x, 15x. And then last, 3 multiplied by 4, 12. Tidy up, 10x squared. We can gather these two like terms together. So 8x plus 15x is 23x. And we still have that 12. And then the last wee one here, same technique. 7x multiplied by 2x gives me 14x squared. Outer, 7x multiplied by minus 3 is minus 21x. Inner, minus 1 multiplied by 2x, minus 2x. And then last, minus 1 multiplied by minus 3 plus 3. Remember, a negative multiplied by a negative gives you a positive. So 14x squared minus 21x minus 2x gives me minus 23x plus 3. Okay, let's look at exercises for that. So page 129 is where these start. So exercise 6B, E and G, that is a ton of questions, right? Do not do them all. In those exercises, they're maybe broke up into wee sections. If you just do a couple from each section, check your answers, then you'll know you're all right. If you're getting them wrong, look at the answer, try and figure out where you're going wrong, and then try a few more until you're getting them right. Okay, so pause, give those a go, and then here's your answers. This might take a wee while. So here's the answers to 6B. One thing I do want to say, remember, yours may be written in a slightly different order from this, but that's fine as long as the sign is with the same term. So for example, see in, let's look at this one, 11, 2ps minus 3pt plus, right, etc. As long as this term here is positive, and this one is negative, and this one is negative, and that one's positive in your answer, then it's fine, it's still right. 6C then, so if you haven't done so already, pause and get that marked. 6C is here. So again, order doesn't really matter as long as you have all the individual terms. Pause, mark whichever ones you got done. D, was D on the list? No, it wasn't. So 6E and 6G. So there's 6E. And then 6G answers are here. Okay. So next thing we did was factorising, which is basically the reverse of that process that we've just done. Do you remember the first one, multiplying out single brackets, where we had to multiply everything in the bracket by one thing? This is really the reverse. So taking a statement like this and putting the bracket back in. So we're really looking and thinking what is common to all the terms here. And remember, terms are separated by pluses and minuses. So 7a squared minus a. If we look at the numbers, first of all, there's a 7 here, and if there's no number in front of something, it's basically a 1, so this is like minus 1a. So 7a squared minus a, number-wise, there's nothing we can bring out. The only thing that is common to both of these terms is a. So the way I do it is I look and see, right, what do I have to multiply a by to give me 7a squared? So I'm going to multiply by 7, and a is going to have to be multiplied by a to give me that a squared. A has to be multiplied by what to give me minus a? Minus 1. Okay, so remember, opposite, if we had been, like this could have been a question we were given earlier on to multiply out. A multiplied by 7a gives us 7a squared. A multiplied by minus 1 gives us minus a. Right, let's look at this one. So in this one here, look at numbers first of all. Well, 15 and 5 can both be divided by 5, so I'm going to bring 5 out of the bracket. Then if we look at the letters, we've got an A and a B here and just an A here. So A is the only thing that can come out. So 5A needs to be multiplied by what to give me 15AB? Well, 5 has to be multiplied by 3 to give me 15. A is there, it's fine. But we're going to have to multiply by B to give us that. Plus 5a, 5a, don't need to multiply by anything, so we have to put a 1 in there so that that term shows up. Do a quick check of multiplying out. 5a multiplied by 3b, 5 times 3 gives us 15, a multiplied by b gives us ab. 5a multiplied by 1, 5a. So this one here, let's look at it. Let's go numbers first of all. 13, 4 and 5. Are there any common factors for those? No, so we can't bring any numbers out. Letters, P, Q, P and Q. There's actually nothing we can factorize in this one. That was a terrible example. Let's just forget that one, sorry. Let's move on to the next one. So, let me see. Numbers in this one first of all. 12, 4 and 8. We have got 4 will go into all of those, so I'll bring 4 out. And letters wise, right, we've got a c squared there, a c and a c cubed. So see if we try to bring out c squared, well, this term here doesn't have c squared in it, so you can only ever bring out like the smallest amount of something. So the only thing we're going to be able to bring out here is c, right? And let's go one term at a time. So 4c has to be multiplied by what to give me this? 4 has to be multiplied by 3 to give me 12. C has to be multiplied by c to give me c squared. Okay, 4c, to get 4c, just multiply by 1. 4c to get minus 8c cubed. So 4 to minus 8 is going to be multiplied by minus 2. And c has to be multiplied by c squared to get us c cubed. So again, we'll check that if we were going the other way around. 4c multiplied by 3c. 4 times 3 gives me 12. C multiplied by c gives me c squared. Happy days. 4c multiplied by 1, 4c. 4c multiplied by minus 2c squared. 4 multiplied by minus 2 gives us minus 8. C multiplied by c squared gives us c cubed. Okay, so if you're practicing some of those, page 141, exercise 7a. Right, there's a crazy number of questions in that exercise, so obviously you're not doing these all. Pick and choose, but check your answers off against this. Okay, the next thing we did was constructing formula. Now, I'm not going to be able to add anything here that isn't already in your notes. So if you just look back over that in your notes, we added in a couple of extra examples because the exercise on this was really, really tricky, unnecessarily so if you ask me. But if you're practicing that, the exercise is exercise 9a, which is on page 181. Okay. So if you want to give some of those a go, and that's the answers for those if you're checking them off. Okay, I would say there's no need really to go much further than definitely not over 10. If you just give a couple of them a go, some of them are stinkers. Right, next little thing we did was substituting into equations. So that's just whenever you replace the letters in the equation with the value that they hold. So we're going to do 2 examples here. So if we had the equation x equals 5a minus 3c, and we could be asked to find x whenever a is 4 and c is 2. So first step is to rewrite the equation. So x equals 5a minus 3c. Then write it, but replace the letters that you know the values of with their value. So x equals 5 multiplied by a, and a is 4. So there's 2 ways you can write this. I'm going to go with my favourite. I can rewrite it the way I think you maybe prefer after. So I tend to write it like that, right? Minus 3 and then c is 2. So this, remember, something beside a bracket just means it's multiplied by it. So 5 multiplied by 4 is 20, minus 3 multiplied by 2 is 6. So I get 14. Now, if you hate that, that's fine. Let's do an alternative. So the other way you could write that would be x equals 5 multiplied by 4 minus 3 multiplied by 2. That's fine. I prefer if you put wee brackets around those though. I do love a good bracket. And then you're working out from there on, it's going to be the same. So 5 multiplied by 4 is 20, 3 multiplied by 2 is 6. So we get 14. Okay. This other one then. So find h when b is 10, c is 2 and a is 1. So rewrite the equation. and then fill in the values that you know. So 3b is 10, so that means 3 multiplied by 10, plus c, which is 2, all over 4 multiplied by a, and a is 1. So 3 multiplied by 10 is 30, plus 2, all divided by 4. So h equals 32 over 4. Oh, works out nicely. It's not like one of my normal examples. Gives us 8. So let's look at a wee exercise for those. Okay, so exercise 9b, exercise 9c. Remember, don't do them all. And here's answers for checking. So 9b, oh, they're both there, 9b and 9c. So check whatever you got done. So next thing was changing the subject of a formula. So the subject of a formula is just the thing that is on its own on one side of the equal sign, most commonly the left hand side. So in this case here, x is currently the subject of this formula, and in this one, b is currently the subject of this formula. Okay, so in both of these, I've said we're going to be making a be the subject. So that means we have to get a on its own on one side of the equal sign. So start off with the original equation, x equals 5a plus c, right? And we're looking to get a on its own. So a is currently getting multiplied by 5 and c is getting added to it. So we need to do the opposite of both of those things. And a wee rule that generally works here is if we go in like reverse BIDMAS order. Okay, so draw my lines down both sides because we're going to be doing the same thing to both sides of the equation, and we always write what we're doing down here. So I said a is getting multiplied by 5 and then c is getting added on. So we need to do the opposite of that. We need to take c away and then divide by 5. So take away c, and for it to remain balanced, do that to both sides. So we get x minus c. And over here, if we have 5a plus c take away c, then we're just left with 5a. Then to get a on its own, we have to divide by 5. So dividing by 5 means this whole thing has to be divided by 5. The easiest way to write it is just like that. And then it's just convention that we write it this way around with the subject on the left hand side. So a equals x minus c all over 5. Now, say you had done that one and at this stage you'd written it a little bit differently. An alternative answer that would also be correct would be a equals x over 5 minus c over 5. Okay, so that would also be right there. Now this one here is a little bit more awkward. So let's start off with our equation. B equals 3 minus 2a. There's my lines. See if the thing that you're trying to make be the subject is negative, which it is in this one. That's really awkward. So the very first thing I would do would be make it to be positive. So I would add 2a to both sides here, right? That's going to give me b plus 2a equals 3. Then a is getting multiplied by 2 and it's getting added to b, so we need to do the opposite of that. So we'll get rid of this b first. We need to take b away from both sides. So here I'm left with 2a, and here 3, take away b, I just write that as 3 minus b. Get a on its own, divide by 2. So a equals 3 minus b all over 2. Okay, so here's 2 exercises if you're wanting to practice that, and the answers are here. So this is 9D here, 10 to 29 wasn't it we said? So these ones here, and then 9E are here. There we go. Move that shadow out of your way. Right, moving on. So the last thing in this topic was sequences, and we did really well on it. So I suppose I'm being a bit lazy here with this first example. If you're told the nth term of a sequence, n just refers to the place value in the sequence, is given by this formula here, and you're asked to find the first 4 terms. Well, the first term, n is going to be 1, so you substitute in 1 for this, which we've done here. Second term, n is going to be 2, so we'll have 2 plus 1 all squared, which I've done here. Third term, n is 3, and it goes on like that. So we important note, n refers to the place in the sequence. So if n is 1, that's the first term. If n is 5, that's the 5th. If n is 561, that's the 561st term. But the difficult bit in this here bit of the topic is if you're given a sequence and you're asked to come up with that formula for the nth term. So that's just the formula that rules the whole sequence. Okay, so I've done this sequence here. So say we had, just repeat myself, say we had this sequence. The nth term, or the place value I should say, this is the first term, so n is 1 for this. This is the second, third, fourth and fifth, right? And then these are the actual terms in the sequence. So it's like the place value. So if you're asked to get that formula for the nth term, there's a wee weird rule that you can use. If you look and you see what the numbers go up by every time, right? Well, in this case, they're going up by 4. And if you multiply n by that number, whatever they're going up by or down by, so the nth term is going to be 4n, but we're not finished because that isn't necessarily right. So go back to your first one. Whenever n is 1 and we multiply by 4, that gives us 4. Well, how do I get from 4 to 3? I take away 1, so I add that onto it. Always check it with some other ones. So whenever n is 2, 4 times 2 is 8, take away 1, gives us 7. Happy days, it works. N is 3, 4 times 3 is 12, take away 1, 11. So it works. So this here number is the number that goes in front of the n, and then you figure that out and see how do I get from whatever that is to whatever this number is, and you'll get there. So sequences exercises. So 9G is like that very first example I showed you there. I just showed the one from the notes where you're given this and then you have to generate the sequence. And then this one here is questions like this one. Okay, so answers for those. So here's the answers to 9G and the first 3 answers to 9H. And then there's the rest of 9H up there. So that was like a wee crash course in algebra. Hopefully it helped, and we are going to be doing our unit test next day. Bye.